Good day, Algebra. We are going over CO2 today, not carbon dioxide, but estimating the root of non-perfect squares. Let's start by defining something that's actually a little bit difficult to put into words. What is a root? Yeah, not the herbology plant root, but the mathematical root. How would you define that? We just talked about it in CO1, so we know what it is, but put it into words. Maddie. Yes, and we define perfect square, non-perfect squares a little bit below, but it's not easy to define, is it? The best that I can come up with, a root is a number that, when multiplied by itself, or when squared, equals the given value. Kind of wordy, okay? But a root is a number that, when multiplied by itself, equals the given value. It's easier, I think, to actually just kind of show it. And we talked about it in CO1 when we said the root of 81 was what? 9. Why? Because 9 is the number that, when you multiply it by itself, equals the given value of 81. Okay? So a root is something times itself that's going to equal the given value. And a perfect square is what? A perfect square. 81, for example, is a perfect square. So is 25. So is 144. So is 400. What am I talking about, Paul? Sure. Okay. What was that? To the same numbers? I thought I heard someone say it. No, yes, but say the other part of this. What makes it a perfect square? Yeah, but there's perfect squares are not, like, examples of perfect squares, like I said, 81, 25, 400. A non-perfect square would be 12, would be 20. What's the difference in those things? You're dancing around it, right? But I'm looking for a little bit of something else. Katie. Right, okay. A perfect square is a number with whole roots. Okay, we reminded ourselves what a whole number was yesterday to kind of talk about it today. A number with whole roots, such as root of 81 is 9, root of 25 is 5. Okay, a non-perfect square would be like 12 and 20 because, well, their roots are irrational. Okay, so a number with irrational roots. And where that term perfect square comes from, and again, I don't remember if we talked about this yesterday or not, but if you have a square with an area of 25, talked about this, what are the lengths of the side of the square? 5, right? It makes a perfect square. Okay? Whereas 12, you can make a rectangle of 2 and 6. You can make a rectangle of 3 and 4, but you can't make a square with factors of 12. Okay? So that's why it's a perfect square or a non-perfect square. You will not be able to use a calculator on this objective on your test. And so the table that we're about to fill out now is going to be extremely helpful, right? Because if you could use a calculator, then all you have to do is just punch buttons in the right order and get the decimal answer and call it good. I'm not interested in that. I want you to actually use number sense to estimate these non-perfect squares. So you can use a calculator right now to check your answer, but you'll not have one on the test, which is why the table we're about to fill out now is going to be super helpful. Yes? This table can go on a help sheet. Yep, it's under the definition section. Definitions, the wise old owls can go on a help sheet. So there we go. Okay, our list of perfect squares. 1 is a perfect square. What's the root of 1? 1. 4 is a perfect square. What's the root of 4? 2. Next perfect square is 9. Its root is 3. Then comes 16. Root is 4. Then comes 25 and 5. 36 and 6. 49 and 7. 64 and 8. 81 and 9. 110. 121 and 11. 144 and 12. 169 and 13. 196 and 14. And 225 and 15. So when I ask you for the root of any number in our perfect square row here, it's going to be a whole number answer, and those whole number roots are written down below. But our purpose today is instead to pick on those non-perfect squares. So let's see, who can I? William, give me a number between 1 and 225 that is not a perfect square. 17. Very well. If I ask you for the root of 17 and ask you for an estimated value, because obviously this being a non-perfect square, we know it's an irrational value. The decimal goes on forever. We're just going to estimate it. We can use what we know about perfect squares to help us. Okay? What two whole numbers do we know the root of 17 has to be between? Paisley? And how do you know that? Yes. The two perfect squares on either side of 17 are 16 and 25. And because 17 falls between them, it means that its value is going to be between the root of 16, which is 4, and the root of 25, which is 5. Okay? You should have covered this a little bit last year in like CO12-ish. Okay? So hopefully light bulbs are flickering here. But what would be the correct estimation for this? Paul? Sure. 4.1, I would accept that. 4.2, I would accept that. How do you know it's not like 4.7? Paisley? Right. The root of 17 is obviously closer to 16 than it is to 25. So our value is going to be closer to 4 than it is to 5. Okay? Questions on this? Okay. Let's just jump right into the fun down here. What's one of these 8 that you want to talk about? Don't worry about the negative ones yet. But one of the first 6. Maddie. 140. The root of 140. Look at your perfect square list. What two perfect squares is 140 between? Okay, so the root of 121, which is 11, and the root of 144, which is 12. Okay, because 140 falls between those two perfect squares, we know that its value is going to be between 11 and 12. Who wants to toss out a logical estimation for this? Eli.
Probably, it's closer to 144.
Mm-hmm. Okay, so 140 is closer to what 144, which means our value will be closer to 12. Eli said 11.8. That would work. I would also accept 11.7, 11.9. If the Packers win, I would accept 11.6. Okay. But yeah, it's an estimation. Doesn't have to be perfect. Okay. When you're working through this assignment for homework, I need to see work here because, again, it's easy just to use a calculator. I don't want you to use one to find it. You can use it to check it. Okay, see how close you got. But I do need to see the work here. work is required. If you come tomorrow with no work shown, only answers, you will not get credit for the assignment. Okay? Another example. Who wants to see another one done? This time you can include the negatives if you want to. Because, spoiler alert, your process doesn't change at all. Colin? Sure. Which one? Negative 215. So with a negative root like that, you can kind of ignore it because the process doesn't change. It just means your answer is going to be negative when you're done. Okay? 215 is still between 196 and 225. So our answer is still going to be between 14 and 15. Only since it's the negative root of 215, really it's between negative 196 and negative 225, which means it's going to be between negative 14 and negative 15. That's the only difference. So is 215 closer to 225 or closer to 196? Closer to 225, right? Here it's 10 away versus 19 away. So it's going to be closer to negative 15 than negative 14. So what are we looking at? Andrea. Negative 14.6, negative 14.7, negative 14.8, any of those, right? So again, same process. You're looking for what it's closer to and estimating it based on that. The negative sign really doesn't come into play much, except for your final answer. Colin.
But if you multiply that by itself, it's going to get to a positive.
Yes, so there's a difference between a negative sign being outside the root than inside the root. Okay? There's a difference between the root of, or the negative root of 16 and the root of negative 16, right? The answer to this one is a negative 4 because you take the root first and then just bring this sign over, which is kind of what we did here. Okay? The root of negative 16 is kind of what you're talking about, where what's two of the same number that multiplies to get a negative 16? Andrea? Negative 4 and 4 gives us negative 16, but are they the same number? No. So it doesn't work, right? Again, I'm going to refer to Algebra 2. Some of you may start to get this on your map test even. If you see the root of negative 16, the answer is 4i. And that I stands for an imaginary number. Basically saying that math teachers weren't really sure how to handle this, so we just made it up. We just imagined it. Not really, but okay. So if you ever see that 4i, that I means it's imaginary, and the reason why is it comes from taking the root of a negative, which is different than the negative sign being outside the root. Okay, it goes back to order of operations. Here the root happens first, then we tack on the sign. Here the sign's included with the root, which causes a problem because nothing times itself is going to give us a negative number. So we just imagine it's 4. Oh, math is fun, isn't it? There we go. Okay. Okay, we get some word problems on page 2. Says, through your grandparents, you find out your family owns a large plot of land in rural Minnesota. An old map they have shows the plot of land to be a square with an area of 200 square miles. The length and width of the plot, however, have faded. The map is old. Approximately how many miles long and wide is the plot of land? So you've got this map with the square on there. You know the area of the square is 200, but you don't know the base and the height. How could you use what you know to find what you don't know? Keeping in mind the concept we're learning today. Maddie.
Well, you could look at the alphabet square. You could see 100 is 10, or is the square root of, or 10 is the square root of 100.
Okay.
You could be like, oh, well, just multiply that by 2.
Unfortunately, roots don't quite work like that. Okay. We're talking about area. How do we find the area of a square? What's the formula, Chase? Length times width, which since it's a square, what do we know about the length and the width? They're the same thing. So really, whatever the base is, the height will be the same thing. It's a square, which means that something times itself equals 200, because 200 is the area, which means if we take the root of 200, that would tell us what that something times itself is, right? If I told you the area of the square was 49, you'd immediately say, oh, 7, 7, right? Because you took the root of 49. Same thing here. Only 200 is a non-perfect square. So now you go back to your table, you see what it's between. It's between the root of 196 and the root of 225. So what would be an estimation of the length and width of this plot of land, Chase? 14, let's decimalize it. 14.1, 14.2, somewhere around there, right? So where this math is applicable is if you know the area of a square, you can then estimate its side lengths by estimating what the root of 200 is, that area. A square bulletin board is an area of 80 square feet. Estimate the perimeter of the bulletin board. So same kind of thing here, right? We have a square. Well, that's not a square. That was horrible. Oh my gosh. That's not good either. We know the area is 80, right? Same kind of situation as we had before, which means that the base and the height are actually the same thing, okay? But this time, instead of just what's the side length of the square, I want the perimeter of the bulletin board. So you now have to draw, you're still doing the same thing, right, as far as finding the root of a non-perfect square. But then how do you translate that to get the perimeter of the bulletin board? Okay. A backyard in the shape of a square is 34 feet, a fence surrounding it. What is the area of the yard? So this time I give you the perimeter. Use that to tell me the area of the yard. And then we talk about cubed roots at the bottom, but we'll talk about that tomorrow after we're done correcting this. Okay. So your homework for tomorrow is all the Mr. Happy Pencil, all the happy globes. This middle section we didn't talk about yet, but you're essentially going backwards. It says write the value of each decimal using a square root. So for example, if the decimal I gave you was 7.1, that would be approximately equal to the root of 50. Okay? Because 7 squared equals 49, 7.1 squared is going to be a little bit more than that. So root of 50. What would 4.5 be? 4 squared is 16. 5 squared is 25. Where would 4.5, a good estimate for that be? The root of what? The root of 20. Sure. It's about in the middle. Root of 21, about in the middle, right? 8.2. 8 squared is 64. 9 squared is 81. What would 8.2 be the root of, approximately? Sure. 67, 68, 69, 70, somewhere in there, right? Okay? So it's kind of going backwards. It's going from the root to the decimal. All right? Okay. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? I think that's all of it. All right. No? Okay. With gusto, folks. That's how you math.
Don't forget to like and subscribe.